there are some engineering marvels out there that end up living rent-free in my head for just years on end, and I go back and I think about how cool they are, but there's a new one that's living in my head, not because of how cool it is, but because of how ridiculous it is. I am talking about Claude Code and their TUI. Now, this tweet caught my attention and has been just eating me alive, and now I have to make a video about it. Okay, so let me just read it to you. Most people's mental model of Claude Code is that it's just a TUI. That's what I thought it was, at least, but it's actually really closer to a small game engine. Okay, whoa. I didn't realize rendering. I mean, I guess if you really think about it, you know, like if you really dig down into the nuts and bolts, you can kind of imagine that a screen, every single one of the characters is kind of like a pixel, right? Which means it's a game, right? Except for your bounds are like 30 by 120 pixels. So, 2,400 pixels. We're talking about pretty easy rendering going on here, right? Like you could make a decision about every single pixel many, many times, right? Whoa there, tough guy. For each frame, our pipeline constructs a graph from React, then lays elements out, rasterizes them in 2D, diffs them against the previous screen, and finally uses the diff to generate an ANSI string. If you're not familiar with ANSI, ANSI effectively is the thing that allows you either to color text that's on the terminal, or B, you can put your cursor in places. You can also clear the screen with an escape sequence, open bracket. 2J would effectively clear the entire screen inside your terminal. There's all these little things. That's how ANSI works, right? It's an escape character plus an open bracket plus some sort of code. Don't worry about ANSI. It's really irrelevant in this situation, other than it just requires a bit more memory to generate. And that's it. And so they have roughly 16 milliseconds frame budget. And so we roughly have 5 milliseconds to go from React to ANSI. That means React takes 11 seconds to lay out something on approximately 2,400 pixels. We're going to talk about this, okay? First off, I'm going to tell you some engineering management takes that I have, okay? And I think they're very, very important. More so, I'm going to give you some, hey, this is how I think you should engineer things. And then lastly, I'm going to show you that I think whatever they're running up against is a design of their own making and a downfall of engineering in the most truest sense. So first off, as an engineering manager, if I had someone come up to me and say, hey, I'm going to make a TUI, and we have all these constraints, and it involves, like, say, frames per second. My very first question would be like, oh, wow, okay, so you must have a bunch of stuff changing on your scene to require stuff to be rendering at that kind of rate, right? Like, what's changing? What's going on? Why do we have to have a frames per second to ever even begin with? I want to know. I want to understand more. And if the answer isn't, we're writing a full-blown game, and every single key press and everything needs to pass through a tick, and we need to have this really verbose, a beautiful way to handle everything, I would go, you gotta stop. Something has gone terribly wrong here. What are you doing? When I hear this, that Claude Code, which if you're not familiar with, is just interacting with a model that lives on the internet that takes seconds to minutes to respond and leaves little breadcrumbs along the way, requires 60 FPS. This, to me, feels like a failure in engineering management and also a failure in engineering. Now, granted, I don't work there. I don't know the constraints they're working against. Maybe, just maybe, there are things that I don't understand that could make this very, very hard, and maybe it's supposed to make sense if I were to understand the difficulty. So I'm willing to concede that I don't understand everything. If I were a manager and I heard this, I would say, no way, back to the drawing board. Now, as far as engineering goes, if I was an engineer attempting to solve this problem, first off, if I had to generate text into a fixed box along with the scroll history background, which is apparently what they want, you should be able to scroll up and see all your previous stuff. And you want to be able to have some dynamic elements on here along with some other stuff. Obviously, I would have to set up a situation in which I have some layers, right? I have my dynamic side of things right here, and then I have my actual scroll back going on right here, and then I have to construct these things to be able to actually draw what's happening on screen, correct? But here's the deal. I would never set up an FPS for this. It makes no sense, and here's why. You only have a few things that cause a render. One, you have input. So when I start typing, I need to see my characters going on to the prompt, right? Okay, so there we go. We have our characters. For whatever reason, Claude Code also wants a throbber, right? That's what they call it, a big old throbber. Something that's like letting you know, like, hey, I'm rendering. Like right here. See, if I say, tell me how to talk to a woman, you can see the throbber right here. It's throbberating. Hey, Claude Code, teaching you how to riz, just in case you're wondering, okay? Treat her as an individual person, not a category. Boom. Nothing says autism like that answer. Hey there. there, fellow woman. I hear you like flour. So you have the throbber, which needs that thing was rendering like what, 3-4 times a second? And then lastly, you have output coming in from Claude. That's really, as far as I can tell, just looking at the UI, things that require a change in the scene to render. So I'm not even dogging on React, despite my feelings about React. I'm just saying this is what you see. Now, none of these happen at effectively 60 frames per second. People aren't typing 60 characters a second. It's not throbbing, plus typing, plus receiving Claude code back at 60 frames per second. So that means you could make the little diff adjustments to your screen as each one of these things come in. There's no running game loop. It should be completely empty if nothing is happening. If you're waiting for Claude, there's no throbbing going on, no characters being typed, there is no work to be done. There's no diffing, there's no reacting, there's no rasterizing, there's no generating of ANSI. You can say no change, no work. It's one of these really beautiful things about writing TUIs is that you can tell when something has changed, therefore you know when work needs to be calculated. And so in my head, this is like what should happen. But obviously, again, I still may not understand things, and I don't want to dog on somebody for some engineering stuff. I don't understand the trade-offs they originally used. I don't understand the React thing, but again, I'm sure you can explain to me why React was a good decision. To me, this just obviously looks like, hey, I want to write TypeScript. What do you write with TypeScript? You write React. Okay, that's what the LLM told me. Hey, I'm an engineer. I use an LLM. Bada bing, bada boom. We use React. Or this comes from some sort of legacy decision that somebody who thinks that they really love TUIs, but they also only just want to write TypeScript was like, yo, there's this library called Ink that uses React, bro, which is, I think, what ended up happening. It doesn't really matter how you got here. That decision was made, but the 60 FPS is really still just living rent-free. Because then I thought, okay, how fast can I render stuff to the screen? So I wrote a tiny little test right here where I can say, I want to draw a box of 1x1 characters and I want to draw it as fast as possible. So I'm drawing this as fast as possible randomly on my screen. This number right here is me drawing 1,000 of those boxes. How many milliseconds did it take? So I drew 1,000 1x1 boxes in effectively 1,000 milliseconds. Okay, that's pretty cool. I do it again. Let's do a 2x2. As you can see, I'm writing a lot more characters. Effectively, no time has changed. I can do that at 32x32. You can see the screen's going nuts. I bet you YouTube encoding is just utterly failing at this point because I have simulated white noise from first principles. Again, I'm also using Ghosty. This is a modern terminal with GPU acceleration, so some of the older terminals probably couldn't render as fast as this. I don't actually know what the real frame rate is because I don't know if we're actually rendering at effectively one frame every 1.3 milliseconds, right? We're rendering some amount at some rate that's very, very astronomically high to the point that I can't even see what's really happening on the screen. Just as far as rendering goes, you can go really, really fast. There clearly is nothing holding back from just going absolutely much, much faster than 60 frames a second, even in a modern terminal. Now, granted, again, legacy terminals, I can't speak for them. I used to use some terminal from 1984. It took everything was much, much slower when I tried to play ASCII Doom. But then I got curious. So this right here is me seeing how fast can I render scroll back history. Okay, so now if I close this, I can actually take tmux and look like that's the scroll back history right there. So this is much closer to what Claude Code does, is it has an input area where I can put in some nice input going on down here. And at the same time, you can imagine I'm getting so much stuff coming back in. Now, granted, I didn't use React. This is not nearly as complicated. I also included a throbber that looks pretty similar and along with like a little braille, little swirly thing. This is how many new lines I have created. This is how much of the time I'm calculating I'm using the CPU in JavaScript land. Approximately for every frame, I'm using 100 microseconds and I'm almost idle the entire time. So again, even with this really ridiculous example, which is just, rendering at an absurd rate and doing a ridiculous amount of stuff, I don't know where the 16 milliseconds is going wrong. It purely seems like a React problem. And don't just take my word for it. Will McGugan, if I'm saying that name correctly, is kind of a long-time engineer out here that has done a lot of stuff, and I think he has a really amazing take on this. Sometimes developers get hyper-focused on tackling the immediate technical challenges in front of them that prevents them from reflecting on past decisions. By the way, this is one of my greatest weaknesses, and even after 20 years of engineering, this right here, it still rings true today. So much of engineering is taking a step back and going, why did I make this decision? Let's actually understand the problem and not just simply the solution. It's like you take a fork in a road and find out you need to climb a mountain. The faster route to your destination may be to backtrack and take a more direct route without the mountain in the way. TUIs are much more complex than most people know. Very true. I've written a couple TUIs in my day. I have some amount of experience in it, but I've never written a TUI to the level of complexity of Claude Code. It is a very impressive TUI. Trust me on this. But I see nothing in Claude's output that needs a scene graph. Their scene is a list of non-interactive output. It's literally a list of things. Granted, there's a little bit of like highlighting, a bit of throbbing. There's some input at the bottom. They want to preserve scroll history. There's a couple things, and apparently you can press like Control B to like expand some stuff. So there's some like accordion interactive stuff, though I've never gotten that to work. Claude Code does not need to be a small game engine. No game engine would construct a scene graph and diff every frame. That would be too expensive and wouldn't scale. I'm an ex-games developer. Yeah, typically you just do immediate mode, right? You just draw the scene, right? You could draw the entire terminal every single time. How do I know? I'm doing it right now. With the scene stored as the list, tracking what changes rather than diffing, the caching ANSI generation, 16 milliseconds for a frame wouldn't be challenging to hit. I don't even think, again, I would argue from the beginning, there is no frame rate you need. You react to changes coming in because they're not going to be that fast. By the way, just in case you're wondering with input, if you did 60 characters per second typing, that's 720 words per minute, okay? Ain't nobody typing that fast. Even if I mash my little fingies as fast as possible, I can't achieve such speed. I think the mountain is the React model, a holdover from their Ink days. It allowed TS developers to use a comfortable pattern for building UIs. But React was designed to manage the complexity of a browser UIs, which are way more complex than Claude's requirements for a terminal UI. Absolutely true. And now Anthropic are expending a lot of engineering effort to tunnel through this mountain. On top of it, this also just goes to show, remember this phrase that people always say, use the best tool for the job? It really just goes to show what people mean when they say that is I'm going to use the most comfortable tool for the job, which is the anti-pattern, by the way. I'm not even upset at JavaScript. I think JavaScript's perfectly fine here. I don't even care about that aspect. Yeah, sure, it's a little bit memory hoggy. Now with RAM becoming the most expensive thing in the universe, I can see why that's negative. But nonetheless, your problem is not performance. This is not a performance problem going on here. If there is a performance problem, it's a you problem. Perhaps the renderer is too coupled to the data model and hard to replace now. I wouldn't be surprised if that were true. But if I were Anthropic, I would have a small team work in parallel to build a kind of decoupled model and renderer that you would make if you didn't have any legacy issues. I would hire at least one games developer for this. Honestly, you could hire a games developer. Just hire a tools developer in general, not even a games developer. Hire somebody that doesn't just build for the web. Really, just anybody else. You could probably hire half the web devs and they could just figure it out. I really think this team would get to their destination before the team that is tunneling through the mountain. Honestly, this is just so true, and I think it's such an interesting point in engineering, right? Because Anthropic has been the leading scaremonger about like the world's gonna end, all the jobs are gonna leave. You look at this, and I see a failure of both engineering management and engineering. They've dug themselves into the weirdest place, and it just goes to show, even if they generated all the code with LLMs and they're saying this is the best ever, fundamentally, the decisions they have made aren't good. And so whether the code was generated by hand or by LLM, it doesn't matter. The failure already happened. Some more highlights from Twitter. We apparently live in a clown universe where a simple TUI is driven by React and takes 11 milliseconds to lay out a few boxes in monospace text. By the way, Visness right here. Excellent blog, excellent engineer. Layout, 0.9 milliseconds. Rasterization, I've never read what rasterization means. I'm sure it's really simple. It's just in my head. I'm like, that's a word I never know. 2.1 milliseconds. Diffing, 1.2 milliseconds. Building the React scene graph, 11 milliseconds. I think this one really is just like, this encompasses how I feel. This company is having a hard time making a 2D ANSI terminal to run at 60 FPS, and they demand you to take them seriously when they talk about revolutionizing programming. I keep saying this, and I feel like this is just so important. Hard skills are still in demand. The LLMs aren't going to make the best decisions. They're going to make the decisions that you tell them to make crappily. It's not only up to you to make the decisions, it's up to you to double check that the decisions you made were even implemented properly and with care. So if you don't have that foundation, you just might find yourself in 60 frames per second React diffing Hellland Hellscape TUI. Lastly, I know this tweet was made by Tariq right here, and a bunch of people kind of been dogpiling him. Hey, my goal wasn't here to like call him out or single him out or try to be mean to him. Hey, I've been in positions in which I've had to make decisions or follow up with past decisions that weren't ideal. that did cause a whole bunch of difficulty. I just was lucky enough not to have to make those decisions and explain myself on Twitter. And I think a lot of you listening have found yourself in a very similar situation. So be nice, be kind. And all my critiques, as you can see, are more towards the leadership of Anthropic, which is their constant fear-mongering of engineering, saying it's all over. Because even within their own company, they suffer from the cost of legacy. There's nothing more permanent than a temporary fix. The name is the Primogen. Hey, is that HTTP? Get that out of here. That's not how we order coffee. We order coffee via SSH, terminal.shop. Yeah, you want a real experience? You want real coffee? You want awesome subscriptions so you never have to remember again? Oh, you want exclusive blends with exclusive coffee and exclusive content? Then check out Cron. You don't know what SSH is? Well, maybe the coffee is not for you.
Terminal coffee in hand, living the